if y is equal to 3 cos of log of x plus 4 sine log of x, we need to prove x square second order derivative of y, x into first order derivative of y plus y is equal to 0, right? So this is all the things that we need to do. Okay, this looks better. Now the proof. So first thing is we need to find the second order derivative. So let's do that. So we have y prime which is equal to 3 sine log x, and as per the chain rule I need to differentiate log x as well. Next we have the second term 4 cos, by the way this is minus log x, and again as per the chain rule we need to differentiate this. So we have the following answer. So this is derivative of log of x. Same thing over here. This is our chain rule. Okay, nothing much we can do over here. We'll just keep that. Then we will take the differentiation with respect to differentiating with respect to x. Next, we again will differentiate with respect to x. So we have y double prime is equal to minus 3. Yeah, here we have a scenario wherein we can take it as a product rule, if not a quotient rule, right? So if I can write 1 by x as x to the power of minus 1, then it becomes a product rule. Or if you guys are okay, we can do quotient rule only. So derivative of the first term, so cos log x into 1 by x into x. That's your first term derivative, that is u prime into v. Then we have minus v prime, that is 1 into u. Okay, this entire expression divided with x square. Again, let me rewrite this so that you guys are not confused. I am doing this. Sine log of x divided by x plus 4 times of cos of log of x divided by x. So this is the funda. So the first term, it looks like this, and now the second term plus 4, again derivative of, so basically u by v, right? So derivative of cos is minus sine log of x, and yeah, as per the chain rule I need to do this as well. So I don't have space for that. Minus, then again the derivative of u, so which in this case again is 1. This entire expression divided with x square. And finally we can simplify this a bit. So here x and x gets cancelled and nothing else. So we have minus 3 cos of log of x minus sine of log of x plus 4 times of minus sine log of x minus cos log of x. We can further simplify this, to be honest. So let me just, oh yeah, and we have divided by x square, So I guess we can just keep this because we have x square over here, then it is easier to simplify. And we have x with your first order derivative of y. So we can multiply with over there and it would be okay. So we'll consider the RHS. So that would be x square times of your second order derivative. So minus 3 into cos of log x minus sine of log x. Then we have minus 4 sine of log x. So this is plus 4 by the way, my bad. Oh no, minus itself. 4 cos of log x, and both of this term are divided by x squared. So it's clear that we need to cancel this in this. Well, let me continue. This is the first term by the way. Second term has an x over there and this particular expression. So this is minus 3 sine of log x plus 4 cos of log x, this thing divided by x, both these terms divided by x, and the last is y. So y itself is this, plus we have the following expression. Now we have this 2 getting cancelled, this 2 getting cancelled, and this is going to be minus 3 cos log x, then plus 3 cos log x. This 2 can get cancelled. Then we have minus 4 sine log x, and this can get cancelled. Then do we have something else? This term and this term should get cancelled, and we have, maybe I did a mistake over here. So this is minus and this is plus. I mean both are plus, sorry. So there's something that I did wrong then. Oh yeah, this is minus 3. So this will be plus by the way. Minus of minus is plus. And so the last term, right? And we have this to be equal to 0, which is equal to our LHS. So that's the advantage of when we have to prove things. We know the final answer. If we go wrong, we can always go back and correct that. Okay, and that's your answer. And by the way, this many steps is enough. You don't have to expand nothing. This is good enough. Have a clear presentation and everything will be okay. You won't lose marks.